December 12th, 1942. Above the rail yards at Rouen-Sotteville, France, the metallic thunder of Wright Cyclone engines filled the winter sky as 23 B-17 flying fortresses of the 303rd Bomb Group released their payloads and turned for home. Lieutenant Paul Flickinger, piloting B-17 F serial number 41-24585, nicknamed Wulfe Hound, maintained his position in the formation as flak bursts peppered the sky around them with black explosions that shook the massive bomber. Then came the fighters. Messerschmitt 109s and Focke-Wulf 190s dove through the formation, their cannon fire stitching lines across aluminum fuselages. Wulfe Hound shuddered as 20mm rounds tore through her wings and fuselage. One engine began trailing smoke, then another. The bomber started losing altitude, dropping away from the protective umbrella of the formation's interlocking fields of defensive fire. Flickinger nursed the crippled fortress northward, desperately seeking any friendly territory, but the mathematics of fuel consumption and structural damage told an inescapable story. They would not make it across the channel. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Near Melun, approximately 60 miles southeast of Paris, with 2 engines dead and the airframe vibrating dangerously, Flickinger spotted an open field and made the decision that would haunt him for the rest of his life. He brought Wulfe Hound down in a wheels-up belly landing, the bomber sliding across the frozen French countryside with a grinding shriek of tortured metal before finally coming to rest. The crew emerged shaken but alive. Within hours, German salvage teams arrived at the crash site. What they found would fundamentally alter German understanding of American industrial capabilities and strategic intentions. This particular B-17, relatively intact despite its forced landing, was about to embark on a journey that would force some of the Luftwaffe's most experienced commanders to confront uncomfortable truths about the air war they were already losing. The story of how Wulfe Hound became an instrument of revelation for the Luftwaffe begins not with Flickinger's forced landing that December afternoon, but with the escalating strategic bombing campaign over Europe and Germany's desperate need to understand exactly what kind of war machine American industry had created. By late 1942, the Luftwaffe faced mounting evidence that the air war over Europe was entering a new and potentially catastrophic phase. British bomber streams had been pounding German cities nightly since 1940, but these raids, while destructive, operated under cover of darkness and relied heavily on area bombing tactics that lacked the precision to systematically dismantle Germany's industrial capacity. The Americans brought a different approach entirely. The United States Army Air Force's doctrine emphasized daylight precision bombing, striking specific industrial targets with the accuracy that the advanced Norden bombsight supposedly provided. This strategy required bombers capable of operating at altitudes where German fighters struggled, and defensive fire proved less effective, flying in tight formations that provided mutual defensive support and mounting sufficient armament to fight their way to and from targets deep inside German territory. The B-17 Flying Fortress embodied this doctrine with remarkable completeness. Designed by Boeing in the mid-1930s and continuously refined throughout the late 30s and early 40s, the aircraft represented American engineering philosophy at its most ambitious. 4 Wright R-18-20-65 Cyclone radial engines, each producing 1,200 horsepower, gave the bomber a maximum speed exceeding 280 miles per hour and a service ceiling of 35,000 feet. More critically, these engines featured turbo superchargers that maintained power output at altitudes where unsupercharged engines gasped for air. The defensive armament was unprecedented for its time. The B-17F model mounted 1350 caliber Browning M2 machine guns, positioned to provide overlapping fields of fire, covering virtually every approach angle. Twin guns in power-operated turrets above and below the fuselage, single guns in flexible mounts at the nose, both waist positions, radio room, and tail position, plus 2 guns in the chin position, created a sphere of defensive fire that German fighter pilots learned to respect and fear. But armament and engines told only part of the story. The B-17's construction philosophy emphasized survivability through redundancy and robust structural design. The airframe could sustain catastrophic damage to multiple engines, control surfaces, and structural components, yet continue flying. Self-sealing fuel tanks reduced the fire risk from incendiary ammunition. Armor plate protected crew positions from defensive fire approaching from predictable angles. The design accepted increased weight and reduced performance in exchange for bringing crews home alive, a philosophy that reflected American strategic thinking about sustained air operations over years rather than months. Intelligence reports about the B-17 had been reaching German commanders since the aircraft's first combat operations in Europe, but fragmentary combat observations and reconnaissance photographs provided incomplete pictures of capabilities and limitations. The Luftwaffe needed hands-on examination of an actual aircraft, systematic testing under controlled conditions, and detailed technical analysis that would reveal not just how the bomber performed, but why American designers had made specific engineering choices. The opportunity came earlier than expected, though not in the way German intelligence had hoped. In October 1942, approximately 2 months before Wulfe Hound's capture, German fighters had managed to shoot down a B-17 that subsequently crashed in occupied territory. The wreckage, though extensively damaged, was carefully collected and transported to Rechlin, the Luftwaffe's primary experimental aircraft testing facility located approximately 100 kilometers northwest of Berlin near Mecklenburg. What German engineers and military commanders saw when examining that wreckage at Rechlin fundamentally challenged comfortable assumptions about American technological capabilities and industrial sophistication that propaganda had carefully cultivated throughout the war's early years. General Feldmarschall Erhard Milch, serving as State Secretary for the Luftwaffe and one of the service's most technically sophisticated senior officers, examined the crashed B-17 personally. His reaction, recorded in documents later recovered by Allied forces, revealed a man who immediately grasped the strategic implications of what American industry had created. The Reichsmarschall, Milch reported, referring to Hermann Göring, told me that there is no cause for anxiety about the American aircraft, and that, four-engined though they may be, we can contemplate future equanimity. I told him that I do not agree. Milch understood what some of his colleagues preferred to ignore. The B-17 represented not an experimental prototype or small-scale production run, but the leading edge of mass industrial production on a scale Germany could not match. Milch continued his assessment with observations that proved prophetic. These are worries I just cannot get over. We have got to accept that one day the enemy bombers attacking Germany will be flying at altitudes of 28,000 or 30,000 feet. Then, Colonel Adolf Galland, chief of day fighter squadrons, and already recognized as one of Germany's most experienced and capable fighter commanders, examined the wreckage with the practical eye of someone who would be responsible for developing tactics to counter these bombers. His assessment cut to the essential characteristics that made the B-17 so formidable. It unites every possible advantage in one bomber, Galland reported. Firstly, heavy armor. Secondly, enormous altitude. Thirdly, colossal defensive armament. And fourthly, great speed. Each characteristic Galland identified posed specific tactical challenges for German fighter operations. The heavy armor meant that the light 20mm cannon and 13mm machine guns that armed most German fighters in 1942 required multiple hits to bring down a fortress. Fighters had to close to ranges where the bomber's defensive fire proved devastating, maintain firing position long enough to inflict critical damage, then break away before other bombers in the formation brought their guns to bear. The enormous altitude capability meant engagements would occur in the thin air above 25,000 feet, where German fighters without adequate supercharging struggled to maintain combat effectiveness. The colossal defensive armament created overlapping fields of fire that made traditional fighter attack approaches increasingly suicidal. The great speed, while not exceptional by fighter standards, was sufficient that bombers in formation could maintain their course toward targets, rather than taking evasive action that would break up formations and leave individual aircraft vulnerable. But examining wreckage provided only limited intelligence value. German engineers could study structural details, measure armor thickness, inspect defensive gun positions, and analyze engine components. What they could not determine from wreckage was how the aircraft handled in flight, what its true performance envelope looked like under various loading conditions, how crews operated the complex systems during combat operations, and most critically, what weaknesses might be exploited by fighters attacking from specific angles or altitudes. Other senior Luftwaffe officers examined the October wreckage and reached less alarming conclusions that aligned more comfortably with official optimism about the air war's trajectory. Generaloberst Hans Jeschonnek, chief of the General Staff of the Luftwaffe and one of the service's most powerful officers, looked at the same evidence Milch and Galland found troubling and saw opportunities rather than threats. "We will fetch these four-engined bombers down just as quickly as the twin-engined ones," Jeschonnek assured his colleagues, "and the loss of a four-engined bomber means a much higher loss to the enemy." Jeschonnek's reasoning followed logical military analysis. A B-17 carried a crew of 10 men, represented an investment of approximately $238,000 in 1942 currency values, required months of production time involving thousands of specialized workers, and consumed scarce strategic materials, including aluminum, rubber, and specialized alloys. Shooting down one fortress eliminated far more enemy resources than destroying a twin-engine bomber with smaller crew, lower cost, and faster production time. If German fighters could maintain favorable exchange ratios, shooting down more fortresses than Germany lost fighters, the mathematics suggested eventual American defeat. This analysis contained fatal flaws that the next 3 years would brutally expose. It assumed German fighter production could match or exceed losses, that pilot training programs could replace experienced aviators killed in combat, that American production capacity had limits comparable to German industrial output, and most critically, that the strategic value of targets destroyed by surviving bombers did not exceed the cost of aircraft shot down. Milch recognized these flaws immediately. His position overseeing Luftwaffe production gave him access to industrial statistics that painted an increasingly grim picture. German aircraft factories, operating under conditions of chronic labor shortages, material scarcity, and Allied bombing that forced dispersal of production, struggled to maintain output levels. American factories, protected by 2 oceans from direct attack, employing millions of workers in purpose-built facilities, with access to virtually unlimited raw materials, were ramping up to production rates that would eventually dwarf German capacity by factors of 5 or 10. The examination of the October wreckage provided enough information to alarm those German officers willing to look honestly at strategic reality. Then, 2 months later, came Wulfe Hound's capture, and suddenly, German test pilots would have the opportunity to fly a B-17 themselves, experiencing firsthand what American aircrews took to war over Germany. The salvage operation began within hours of Flickinger's forced landing near Melun. German ground forces secured the crash site immediately, preventing French resistance members from reaching the aircraft or destroying sensitive equipment. Specialized Luftwaffe salvage teams, experienced in recovering crashed Allied aircraft across occupied Europe, arrived with the transport equipment and technical expertise needed to move the damaged bomber. Initial assessment proved encouraging from the German perspective. Wulfe Hound had sustained significant battle damage, multiple engine hits, punctured fuel tanks, damaged control surfaces, but the basic airframe remained structurally sound. The belly landing had caused additional damage to the lower fuselage and destroyed the ball turret, but most major components appeared repairable. More importantly, the crew had not had time to destroy sensitive equipment before capture. The Norden bomb site remained intact, providing German intelligence with detailed information about America's most closely guarded bombing technology. The bomber was carefully disassembled for transport, loaded onto specialized trailers, and moved to Leeuwarden Airfield in the Netherlands, which had been captured by German forces during the 1940 invasion and converted into a Luftwaffe base. At Leeuwarden, skilled technicians began the systematic work of restoring Wulfe Hound to flying condition. The repair process revealed the sophistication of American manufacturing techniques and the quality of materials used throughout the aircraft. Unlike some German aircraft whose production quality had begun declining due to material shortages and the use of forced labor with inadequate training, the B-17 demonstrated consistently high manufacturing standards throughout every component and assembly. Rivets were properly set, welds met exacting specifications, control cable rigging showed precise adjustment, electrical systems used high-quality insulation and proper shielding, hydraulic lines featured robust fittings less prone to failure under combat stress. German technicians cannibalized components from other crashed B-17 seconds scattered across occupied Europe, building an inventory of spare parts that could be mixed and matched to create one fully functional aircraft from multiple damaged machines. Wright Cyclone engines underwent complete teardown and inspection, with damaged components replaced by salvaged parts from other wrecks. The turbo-supercharger system, which enabled the B-17's high-altitude performance, received particular attention as German engineers sought to understand the engineering that allowed sustained power output above 25,000 feet. Control surfaces were carefully examined for structural integrity and proper balance. The hydraulic system that powered the turrets underwent pressure testing to locate leaks and ensure reliable operation. Fuel tanks with combat damage were patched using techniques developed through experience repairing German aircraft. The electrical system, complex by 1942 standards with its multiple generator systems and extensive distribution networks, powering everything from turret motors to oxygen system heaters, required systematic troubleshooting to identify and repair battle damage. The ball turret, which had been destroyed during the belly landing and was one of the B-17's most distinctive and vulnerable features, could not be repaired with available materials. German engineers simply sealed the opening, accepting the loss of two 50-caliber machine guns in exchange for getting the rest of the bomber airworthy. The remaining defensive armament was carefully inspected but left installed, giving German pilots the opportunity to evaluate firing positions and fields of fire during test flights. After approximately 2 weeks of intensive work, Wulfe Hound was declared ready for flight testing. The bomber now wore German markings, the distinctive black Balkenkreuz crosses of the Luftwaffe replacing the white star in circle insignia of the United States Army Air Forces. The code DL+XC was painted on the fuselage, identifying the aircraft as assigned to Rechlin's test facility. Following standard German procedures for captured aircraft, the entire underside received a coat of bright RLM-04 yellow paint, making the bomber instantly identifiable to German anti-aircraft gunners who might otherwise assume any four-engine bomber was hostile and open fire. On March 17, 1943, approximately 3 months after Flickinger's forced landing, Wulfe Hound flew again, this time with a German test pilot at the controls and escorted by 2 Messerschmitt 110 night fighters to ensure safe passage through areas patrolled by Allied aircraft and protected by German anti-aircraft defences. The flight from Leeuwarden to Rechlin proceeded without incident, and the first intact B-17 Flying Fortress, captured by the Luftwaffe, arrived at Germany's premier testing facility for systematic evaluation. What German test pilots discovered when they climbed into Wulfe Hound's cockpit and advanced the throttles would fundamentally challenge everything they thought they understood about American aviation engineering and industrial philosophy. Rechlin, officially designated Erprobungsstelle Rechlin, represented the pinnacle of German aviation testing infrastructure, established in 1918 and expanded throughout the 1920s and 30s. The facility featured extensive workshops, equipped with specialized tools and measuring equipment, multiple runways configured for different testing protocols, hangars large enough to accommodate the largest German aircraft under development, wind tunnels for aerodynamic testing, engine test cells with sophisticated instrumentation, and quarters for the test pilots and engineering staff who spent months evaluating new aircraft designs and captured enemy types. The test pilots assigned to Rechlin ranked among the Luftwaffe's most experienced and skilled aviators. These men had thousands of flying hours across dozens of aircraft types, understood the subtle relationships between design choices and flight characteristics, could detect handling anomalies that indicated dangerous tendencies before they became critical, and possessed the technical vocabulary to communicate their observations precisely to engineers who would analyze and report their findings. Hans-Werner Lurch, one of Recklin's most experienced test pilots, drew the assignment to conduct initial flight evaluations of Wulfe Hound. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Lurch had joined the Luftwaffe in the mid-1930s and accumulated extensive experience testing both German and captured Allied aircraft throughout the war. His memoir, published decades after the war as Luftwaffe test pilot flying captured Allied aircraft of World War II, provided detailed accounts of his experiences with various enemy types, including the B-17. The initial flight briefing involved careful study of whatever documentation German intelligence had managed to acquire about B-17 operating procedures. American flight manuals for the type existed in German files, captured from crashed bombers or obtained through intelligence sources, though whether complete copies were available for Wulfe Hound's first flights remains unclear from surviving records. German engineers had examined the cockpit layout, identified primary flight controls, engine controls, system switches, and instrumentation, creating annotated diagrams in German that test pilots would need during their evaluation flights. The B-17's cockpit immediately impressed German pilots familiar with the cramped confines of Messerschmitt 109 and Focke-Wulf 190 cockpits. The flight deck was spacious by fighter standards, befitting an aircraft with a 10-man crew that would spend 8 to 10 hours airborne during missions deep into Germany. The pilot sat in the left seat with excellent forward visibility through the greenhouse-style nose glazing. The co-pilot occupied the right seat, able to take control if the pilot was wounded or killed. Between and slightly behind them sat the flight engineer, monitoring engine instruments and managing fuel transfer between the bomber's multiple tank systems. Controls were logically arranged and positioned within easy reach, reducing pilot workload during the long missions that were the B-17's primary role. 4 large throttle levers, one for each engine, dominated the center pedestal. Propeller controls, mixture controls, and turbo supercharger controls occupied positions immediately adjacent to the throttles, allowing single-handed operation of the entire engine management system. The control yoke moved conventionally, pushing forward to nose down, pulling back to nose up, turning left or right to bank in the corresponding direction. Rudder pedals controlled yaw in the conventional manner. Instruments were clearly marked with easily readable gauges and sensibly grouped by function. Engine instruments clustered together, showing oil pressure, oil temperature, cylinder head temperature, manifold pressure, and RPM for each. Power plant. Flight instruments occupied prime position directly in front of the pilot. Artificial horizon, airspeed indicator, altimeter, vertical speed indicator, turn and bank coordinator, magnetic compass, all positioned where a quick scan provided complete situational awareness. Navigation instruments included a radio compass and various communications equipment far more sophisticated than the radios German bombers carried. Lurch completed his pre-flight inspection, noting the robust construction and high build quality throughout the airframe. American engineers had clearly prioritized survivability, accepting weight penalties in exchange for structural strength that would bring damaged bombers home. He settled into the left seat, the co-pilot's position occupied by another German test pilot serving as backup, and began the engine start sequence. The Wright Cyclone engines caught and settled into the characteristic radial engine sound, a deep rumbling that shook the massive bomber. Lurch advanced the throttles carefully, feeling how the engines responded to control inputs. Power built smoothly and predictably, without the sudden surges or hesitations that indicated poor carburation or inadequate fuel delivery. The turbo superchargers, those critical components that gave the B-17 its high-altitude performance advantage, functioned exactly as American designers had intended. The takeoff roll demonstrated the bomber's surprising agility for such a large aircraft. Despite weighing over 35,000 pounds empty and capable of gross weights exceeding 65,000 pounds when fully loaded with fuel, bombs, and ammunition, Wulfe Hound accelerated briskly down Recklin's runway. The tail came up smoothly as speed increased. At approximately 90 miles per hour, Lurche eased back on the control yoke and the bomber lifted off, climbing away from the airfield with power and authority that exceeded his expectations based on the aircraft's size. Once airborne, Lurche began systematic evaluation of handling characteristics across the flight envelope. He established level flight at various speeds and altitudes, noting how the controls felt and responded. The B-17 demonstrated beautifully harmonized flight controls with aileron, elevator, and rudder forces, perfectly balanced across the entire speed range, from approach speeds through maximum velocity. Control forces increased predictably with speed, providing good feedback without becoming excessively heavy, and decreased smoothly at lower speeds, without becoming overly sensitive or requiring excessive input to achieve desired responses. Roll rate, the speed at which the bomber could change bank angle, proved surprisingly good for such a large aircraft. While not matching the exceptional roll performance of fighters, the B-17 could execute banks and turns with reasonable speed, allowing evasive maneuvering when attacked. The ailerons remained effective throughout the speed range, providing crisp response without excessive control force. Pitch control demonstrated similar virtues. The elevators provided adequate authority to rotate the bomber smoothly during takeoff, establish climbs or descents during flight, and flare for landing without requiring excessive back pressure on the control yoke. The aircraft maintained stable trim conditions once established, requiring minimal pilot input to hold altitude and heading during cruise flight. Rudder effectiveness impressed Lurche particularly. The twin vertical stabilizers and rudders provided powerful yaw control, essential for maintaining coordinated flight with one or more engines inoperative. German bombers, particularly those with inline engines mounted in the nose, often suffered from inadequate directional control when engines failed. The B-17's design, with engines distributed along the wings and large vertical surfaces providing strong stabilizing influence, demonstrated American engineering's attention to single-engine and multi-engine out scenarios that combat operations made inevitable. Climb performance revealed one of the bomber's most significant tactical advantages. The B-17 could maintain excellent climb rates to altitudes well exceeding 25,000 feet, where the turbo-supercharged engines continued producing substantial power, even as the progressively thinner air severely degraded performance in German aircraft equipped with mechanical superchargers or no supercharging at all. Lurche noted in his post-flight report that the Fortress climbed to 30,000 feet with power to spare, reaching altitudes where most German fighters of 1942 vintage struggled to intercept effectively. High-altitude performance particularly concerned German tactical planners because American bomber formations typically operated between 25,000 and 30,000 feet, where the air was thin and cold, but defensive fire from bombers remained effective against fighters that had slowed to attack speeds. German fighters, equipped with mechanical superchargers, struggled increasingly to intercept effectively at these altitudes, their engines gasping for sufficient air, while the B-17's sophisticated turbo superchargers continued delivering robust, reliable power. The revelation proved sobering to pilots and commanders who understood the implications. The B-17 could not only reach these altitudes but could fight there effectively, maintaining speed, advantage, and maneuverability, while German interceptors labored with reduced power, slower speeds, and degraded handling as their engines fought against the thin atmosphere. Speed trials conducted under controlled conditions at various altitudes confirmed the bomber's performance advantages. The B-17F could achieve approximately 287 miles per hour at 25,000 feet when operating at normal combat power settings. This was not exceptional speed by fighter standards, but it was per 5, sufficient to force German fighters to commit fully to intercept runs rather than loitering and selecting optimal attack positions. Lurche's evaluation report emphasized characteristics that translated directly into tactical challenges for fighter operations. The B-17 could maintain formation integrity under attack rather than breaking up and leaving individual bombers vulnerable. It could climb to altitudes where German fighters lost effectiveness. It could sustain battle damage that would destroy lighter German bombers. The turbo superchargers, which German engineers examined with particular interest, enabled sustained high-altitude operations that German aviation technology could not match with production aircraft available in 1943. The defensive armament received careful evaluation through mock combat exercises with German fighters. Rechlin test pilots flew captured Wulfe Hound, while operational Luftwaffe fighter units sent their aircraft to practice attack runs, allowing both the bomber crew and attacking fighters to evaluate firing positions, fields of fire, blind spots, and effective engagement ranges. These exercises revealed uncomfortable truths about B-17 defensive capabilities. The 1350 caliber machine guns, when properly manned and coordinated, created overlapping fields of fire that covered virtually every approach angle. Fighters attacking from the classic 6 o'clock position, directly astern where many German fighters concentrated their armament for maximum forward firepower, faced twin 50 calibers in the tail position firing directly at them. Attacks from below encountered the belly turret's twin guns. Attacks from above faced the dorsal turret. Attacks from the beam positions met waist guns and potentially turret fire as well. German fighter pilots discovered that closing to the ranges necessary for their lighter 20mm and 13mm weapons to inflict critical damage meant exposing themselves to concentrated defensive fire from multiple gun positions. The heavy 50 caliber Browning M2 had effective ranges exceeding 1,000 yards, far greater than the lighter weapons arming many German fighters in 1942. Pilots had to run a gauntlet of defensive fire, maintain firing position long enough to hit critical components or crew positions, then break away before other bombers in the formation added their fire to the engagement. The exercises also revealed the B-17's few vulnerabilities. Head-on attacks, approaching directly from 12 o'clock with high closing speeds, limited exposure, time to defensive fire, and concentrated the fighter's forward-firing armament against the bomber's least armored frontal aspect. The engines, prominent and vulnerable, made excellent aiming points. Accurate fire that disabled two engines on the same wing, particularly the outboard engines where control leverage was greatest, could force a bomber out of formation and leave it vulnerable to follow-up attacks. But even these tactics carried substantial risks. The high closing speeds of head-on attacks left little time for aimed fire before the fighter had to break away to avoid collision. The B-17F had defensive guns in the nose that could fire forward, though not as effectively as later G models with their chin turrets. And perhaps most critically, fighters making head-on runs exposed themselves to collision risks and friendly fire from their own aircraft, also attacking the formation. Following the initial flight testing and tactical evaluation at Rechlin, Wulfe Hound embarked on an extensive tour program that would prove far more valuable for German pilot training than any technical intelligence gathered about the aircraft's specifications and performance. The Luftwaffe recognized that technical data alone provided limited tactical value if frontline pilots lacked first-hand understanding of enemy aircraft capabilities. A pilot who had never seen a B-17 up close, who had never observed its flight characteristics during maneuvering, who had never attempted mock attacks to understand optimal approach angles and vulnerable points, entered combat at severe disadvantage against opponents he did not truly understand. The demonstration program addressed this knowledge gap systematically. Wulfe Hound would visit operational Luftwaffe fighter bases across Germany and occupied France, providing hands-on educational opportunities for pilots who would face formations of these bombers over the Reich. The visits followed a standardized format designed to maximize learning while maintaining security around the captured aircraft. The bomber would arrive at a base, typically escorted by German fighters to prevent any possibility of Allied interception, and taxi to a prepared dispersal area where ground crews had established security perimeters. Fighter pilots and technical personnel from the host unit would gather for briefings conducted by Rechlin test pilots who had accumulated extensive flight time in the captured fortress. These briefings covered the B-17's specifications, performance characteristics, and most critically, the tactical observations drawn from systematic testing and mock combat exercises. Test pilots described the bomber's speed at various altitudes, its climb performance, its service ceiling, and its defensive armament coverage. They explained blind spots in the defensive fire pattern, optimal attack angles that minimized exposure to defensive guns, and specific vulnerable points where accurate fire would inflict maximum damage. Following the briefings came static displays where pilots could approach Wulfe Hound, examine the exterior, and inspect the interior. German pilots climbed through the aircraft, studying crew positions, noting sight lines and fields of fire, examining the gun turrets up close, inspecting the bomb bay, and gaining physical familiarity with an aircraft they had previously known only as targets, glimpsed during high-speed attack runs. The educational value of these close inspections proved substantial. Pilots who had attacked B-17 seconds in combat could now understand why certain approach angles had drawn intense defensive fire, while others had seemed strangely uncontested. They could see how the turrets rotated and where mechanical limitations restricted gun elevation or depression. They could examine the armor plate protecting critical crew positions and understand why some hits that seemed solid had produced no visible effect, while others had caused immediate catastrophic damage. Then came the flight demonstrations, the most valuable component of the entire program. Reclin test pilots would fly Wulfe Hound through carefully choreographed aerobatic routines and tactical maneuvers, demonstrating specific capabilities in ways that written reports or verbal briefings could never convey with equal impact. High-speed passes at low altitude showed the bomber's surprising speed, dispelling any lingering assumptions that such a large aircraft must be slow and ponderous. Climbing demonstrations displayed the fortress's ability to gain altitude rapidly, reaching heights where many German fighters struggled to follow. The test pilots would execute banks and turns, showing the bomber's maneuverability and how formations could adjust heading without breaking up. They would demonstrate single-engine flight, shutting down one or more engines to show how the remaining power plants maintained control and even sustained flight under conditions that would force many aircraft to crash immediately. Mock dogfights provided the most dramatic and instructive component of the demonstrations. German fighters from the host base would engage Wulfe Hound in simulated combat, attempting to press home attacks while the bomber maneuvered defensively. The exercises revealed with uncomfortable clarity how difficult it was to achieve and maintain firing position against a well-flown fortress. When fighters attempted stern attacks from the classic 6 o'clock position, the bomber's tail gunner position, equipped with twin 50-caliber machine guns, could track and engage throughout the approach. Fighters attacking from the beam positions found themselves exposed to fire from multiple gun stations as they crossed the bomber's flight path. Attacks from below or above encountered the belly and dorsal turrets, remotely controlled gun positions that could traverse and elevate to cover wide arcs around the aircraft. The most sobering revelation came when German fighters attempted to employ tactics that had proven successful against British bombers. The standard Luftwaffe approach of attacking from astern in a slight climb, which positioned the fighter in the Wellington or Stirling's less defended lower hemisphere, proved suicidal against the B-17. The belly turret tracked and engaged throughout the entire approach, forcing the attacking fighter to break away or accept catastrophic damage. German pilots who participated in these mock combat exercises consistently reported being impressed and troubled by what they experienced. The B-17 was not invincible, they noted in debriefings, but destroying one required tactics that exposed the attacking fighter to substantial risk. Multiply that risk by the 20 or 30 bombers in a typical combat box formation, each adding its defensive fire to the engagement, and the mathematical certainty of fighter losses became inescapable. One particular demonstration at an airfield hosting Jagdgeschwader units during late 1943 illustrated the uncomfortable truths these exercises revealed. The base commander had arranged for several of his most experienced pilots to fly mock engagements against Wulfe Hound, seeking practical knowledge they could pass on to squadron mates who lacked combat experience against American heavy bombers. The German pilots, flying Messerschmitt 109s and Focke-Wulf 190s, attempted standard fighter tactics against the captured fortress. They quickly discovered that approaches which worked well against less heavily defended targets proved ineffective or catastrophically dangerous against the B-17's layered defensive fire. When they tried to engage from positions where defensive fire seemed lighter, the bomber's speed and maneuverability allowed it to maintain disadvantageous angles, or extend away before the fighters could press home their attacks. The exercises demonstrated that successful attacks required either exceptional skill and favorable circumstances or accepting substantial casualties to overwhelm defensive fire through sheer numbers of attacking fighters. Neither option offered German fighter forces a sustainable path to victory in the developing air war over Germany. Following the flight demonstrations and mock combat exercises, senior pilots would often receive the extraordinary opportunity to actually fly Wulfe Hound themselves, experiencing American engineering and design philosophy firsthand through the controls. These flights proved revelatory for German aviators accustomed to aircraft that prioritized raw performance over ease of operation and crew survivability. The B-17 flew like what German test pilots described as an old man's airplane, meaning it was forgiving, stable, and required neither exceptional strength nor delicate touch to operate effectively. This design philosophy reflected American training doctrine that emphasized producing large numbers of adequately skilled pilots rather than the German approach of creating smaller numbers of highly skilled aviators. An average American pilot could extract good performance from a B-17 under most conditions, while exceptional pilots could achieve remarkable results by fully exploiting the aircraft's capabilities. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.